Okay, and so now at this point, you might have noticed something that I forgot to do in the last video. All right, and I didn't technically forget. I just wanted to point this out to you that you don't want to forget to plug in your number here into the function before you start doing some of these techniques here. So here in part A, when I plugged it in, I got 0 over 0, and so that's why I'm trying to use these trigonometric identities and important trigonometric limits to figure out the limit. Of course, if I plugged in 0 and just got a number, then I was done. I didn't need to do anything. All right, so looking at this limit, the limit as x approaches 0 of x over sine of x, when I plug in 0, again, I get 0 over 0. And so you want to make sure that you're writing 0 over 0 above the equal sign. Okay, and the reason why I'm saying above is because you're not saying that this limit is equal to 0 over 0. It's not. It's just you're telling me that you understand that when you plugged it in, you got 0 over 0. And so you're going to do this algebraic technique now. But you're not saying to me that the limit is equal to 0 over 0. Okay. So what are we going to do about this situation here? Because this looks a little bit like, again, this important property, the limit as x approaches 0 of sine of x over x, but I have it flip-flopped. I have x over sine of x. So somehow I got to do some algebraic manipulation to get to that limit. That's the idea here. So I'm going to do something kind of weird, but this is what I'm going to remind you of here. So, x over sine of x is actually just equal to 1 over sine of x over x. And so I'm not sure if we're completely convinced of this. If you're not, let's just check it. So I'm going to check it. I'm going to check. I'm going to say, okay, well, 1 over sine of x over x is equal to 1 times, let's multiply by the reciprocal, right? Because when you have a fraction, and you're trying to, when you have a fraction divided by, and when you have a number divided by a fraction, what you do is you take that number and then you multiply it by the reciprocal. And so here I do have that this is just x over sine of x. So we checked it. Now we're fully convinced. Even though this seems to completely come out of thin air, that I just came up with that, it did in a way, but it didn't. This is just coming from experience. These are the kinds of things that after a while of doing math, you just pick up on these little tricks. And so I'm exposing you to them because that's really what's going on when you're trying to find limits algebraically. We're doing a lot of tricky algebra. And so I know it's complicated. I know it's tough, but you will eventually get a lot better at this. And so just keep trying and keep trucking through it. Okay. So from here, I'm going to say, well, then this is the limit as x approaches 0 of 1 over sine x over x. Okay, and so now, why was this important to me? This might not have been completely obvious here. Because what I'm going to do is I'm actually going to use another property of limits here. Because what I have is I have a quotient because I have something divided by something. All right, and so what I'm going to do is I'm going to say, well, then this is the limit as x approaches 0 of 1 divided by the limit as x approaches 0 of sine of x over x. And so I know by, again, properties of limits that the limit as x approaches 0 of 1 is just 1. So I have 1 divided by, and then the limit as x approaches 0 of sine of x over x is just 1. That's my properties of limits there. And so I made a big fraction, but 1 divided by 1, that's just 1. Okay. So yeah, so that's what, in terms of doing this, you really just want to pick up on the fact that the limit as x approaches 0 of x over sine of x is also 1. Okay, because that is going to be huge in terms of finding other limits. All right, so you want to just remember that idea, that important limit as well. It's a variation of the first limit, that the limit as x approaches 0 of x over sine of x is also just 1. And so I've, in air quotes, proved it to you. I've shown you why that's the case.